times v minus v du. Okay, v du. So here this formula. Okay, so this formula means the integral. So this means integration by parts. Integration by parts. Okay. So this formula, you must remember it. Okay. So here, the indefinite integral of u dv equal to u times v minus integral v du. Okay. So this is the integration by parts. Okay. So here I write it in. So here is u dv equal to u times v minus v du. Okay. So here u and v is the functions of x. Okay. Is functions of x. So here u dv equal to u v minus v du. Okay. So this formula you must remember it. Okay. We will use it many times. Okay. So now I give an example. So for this example now, example 1, use the integration by parts to evaluate the definite integral, the antiderivative of x cosine x dx. X cosine x dx. Now, okay. So for this antiderivative x cosine x dx. So here actually we can choose this x times cosine x, that is be u. Okay, and x dv. So if we let u equal to x times cosine x, and we let v equal to x. So if we use this formula, so actually here is u dv. Yeah. So equal to what? Equal to u times v. Yeah. U is this function. U is x cosine x, and v is what? V is x. So minus what? Minus v du. V is x. Du, u is what? U is x cosine x. Yeah? Yeah. So here now, let's see dx cosine x actually equal to what? So now we know dx cosine x dx. Okay? Dx actually equal to the derivative of x times cosine x. So equal to x prime times cosine x plus x times cosine x prime. Yeah. So x prime actually is what? Is 1. Yeah. So here actually is cosine x plus x. Cosine x prime actually is what? Is minus sin. Yeah. So here is minus sin x. So here means what? From here means dx cosine x actually equal to cosine x minus x sin x dx. Yeah? So from here we can obtain here actually equal to x times x squared, and cosine x minus here is x times this part. This part equal to here. This part actually is what is cosine x minus x sine x dx. So here now we can see that actually this function of this antiderivative actually is antiderivative of an easy function, but here is a complicated function. Yeah. Yes. So here means what? Here means this choose if we choose u equal to x times cosine x, we choose v equal to x. This is not a good choose. Okay. This is not a good choose. So here from here we know we need to find the other choose. Okay. So here, for example, we have another choose. Here, x times cosine x dx. Okay. If we let this part, if we see this part, cosine x dx. Okay. If cosine x dx, this part. If we see this part, so here, cosine x. Cosine x, if we let cosine x times dx, okay, so this one we see it as a function. So which function derivative equal to cosine x? Sine x, yeah? So here means what? Here means d sine x dx, yeah? D sine x dx equal to what? Equal to cosine x, yeah? So d times dx on both sides. So here we have d sine x equal to cosine x dx. Yeah? Yeah? So here we can write the cosine x dx this part. Okay? We can write it in d sine x. D sine x. So here we can write it this part as x d sine x. Yeah? So here if we write it in this form, okay? So we let u, this x is u, and we let sine x is v, okay? Sine x is v. So here actually we will write this antiderivative in u dv, yeah? So u dv. So u dv we use this formula, okay? We use this formula equal to what? Equal to u times v, yeah? So here equal to u times v, u is x, v is sine x, so u times v minus what? Minus v du, yeah? V is what? V is d, is sine x, yeah? So here is v du, u is x, so du actually is dx, yeah? So here is dx. So so from here we can see here this is a complicated antiderivative, but here is easy, yeah, a simple. So here means what? Here means actually we let u equal to x, and we let v equal to sine x. This is a good choice, okay? This is a good choice. And now, so the antiderivative of sine x is what? Is minus cosine, yeah? So here actually the result actually is x sine x minus cosine, so plus cosine, yeah? And do not forget here we have a constancy, yeah? So here means that, okay? Here means that if we let u equal to x and v equal to sine x, this is a good choice. Because this choose we can transfer this the antiderivative of a complicated function to an antiderivative of an easy function. Yeah. So here this is a choose. So actually we have another choose. Okay. We have another choose. For example, here is x. Here is cosine x dx. So actually we can let x times dx. Okay. So here actually this is equal to what? This is equal to cosine x times x dx. And the x dx, so here which function, okay, which function antiderivative of which function derivative is x? Which function derivative is x?
1x, 5x.
Which function, okay, which function derivative equal to x? So here means what? Here means the antiderivative of x is what? It's half x squared by 2, yeah? X squared by 2, so here means what? Here means dx squared by 2 dx equal to x, yeah? So here means what? Here means dx squared by 2 equal to what? Equal to x dx, yeah? So here means that, here means x dx, okay? X dx, we can write it in d 1/2 x squared. So here actually is equal to cosine x d half x squared, okay? So if we write it in this form, okay, and we let u is cosine x and v is 1/2 x squared, 1/2 x squared, okay? So if we let u equal to cosine x and v equal to 1/2 x squared, so now we use this formula, okay? We use this formula, so here equal to what? So here equal to u times v minus, yeah, minus here is v du, yeah? So here is half x squared du actually is d cosine x, yeah? So d cosine x actually equal to what? D cosine x actually is, we know that d cosine x dx equal to what? So the derivative of cosine is minus sine, yeah? Minus sine, so here is d cosine x equal to minus sine dx, yeah? So here means what? So here means this equal to 1/2 x squared times cosine x minus here is 1/2 x squared sine x dx. So here minus so plus. So now we can see here we need to find the antiderivative of 1/2 x squared times sine x, okay? So now we can see if we let u equal to cosine x, v equal to 1/2 x squared, actually we can transform the antiderivative of x cosine x into the antiderivative of 1/2 x squared sine x. So for this two, okay, for this two, which is simple, which is complicated? Actually, this one is simple, yeah? Because here is x to the power 1, but here is x to the power 2, okay? So actually, so this is complex, and this is simple, okay? So here means we transform simple to complex. So here means that if we let u equal to cosine x, v equal to 1/2 x squared is not good choose, okay? Is not good choose. So here means what? So here actually, if this is the right choose, okay? So this is the right choose.
Yes. Really.
So can you understand?
You want to example?
No, this is the example.
One more.
Then I have give you one more example. But first here, first you must remember this formula, okay? First remember this formula, and now the most important is how to choose u and how to choose v, okay? How to choose u and how to choose v. So here now let's see we have a sentence in the book, okay? So there is another use for charging for choose u and dv that can be applied when the integrand is a product of two functions from different categories in the list. So here means we choose u to the logarithmic. The logarithmic means the log of base a b, okay, of b. So this is the logarithmic function, okay.
Yes.
And here inverse charge law magic. Inverse charge law magic actually charge law magic is what? Is sine cosine. So inverse charge law magic actually is arc sine or arc cosine or arc tangent, arc cotangent, okay? So this inverse charge law magic means the arc sine, arc cosine, arc tangent, arc cotangent, okay? And algebraic means actually means the x square, x cube, so polynomial, okay? Polynomial. And the charge law magic actually means what? Means sine, cosine, tangent, cotangent, okay?
Yes.
Second, cosecant. And exponential means a to the power x, like this, okay? Or ex, like this function, okay? So here, this okay, this part give us a useful suggestion, okay? A useful suggestion. So here means what? Here means if a function here means what? Here actually we want to do like this, okay? So here, so antiderivative of a function times another function, okay? Dx. A function times another function. So now we want to choose u and v. Choose u and v. Plus symmetry, okay? Okay? Choose u and v plus symmetry. So here we want to transfer it a new integrand. That is easy. Easier to evaluate. Okay, evaluate. So here we want to do this thing, okay? We want to do this thing. Here means this is antiderivative, okay? A function times another function. So we want to choose u and v and use the integration by parts to transfer the antiderivative of two functions to a new integrand that is easier to evaluate, okay? So here means in this. So how to choose u and v actually comes from a lot of practice, okay?
Yes.
Comes from your experience, okay? So here means that you need to do many exercises, okay? And now actually here many people do these things. So actually we have experience. So this is the experience, okay? This is the experience. So here means that we need to choose u, okay? So here, the choose of u should be the first is the logarithmic, okay? Logarithmic function. This is the first choose, okay? The first choose is the logarithmic function. The second is the inverse charge law metric. Inverse charge law metric function. This is the second choose, okay? The second choose. The third choose is what? The third choose is algebraic. Algebraic function. So this is the third choose, and the fourth choose. The fourth choose means the trigonometric function, and the last choose means the exponential. Exponential function, okay, exponential function. So here, for convenience of you to remember, so we can remember it by, we take the first letter, okay, we take the first letter. So here actually you can remember it by L-I-A-T-E, okay, L-I-A-T-E. Here L means the logic-magic, okay. The second means the inverse trigonometric function. The third means the algebraic function. The fourth means the trigonometric function. The last one is exponential. So here, this is the choose U, okay. So here means, for example, we have a function. We have any derivative of ln x times dx dx, okay. So for example, we have this, okay. We need to find any derivative of this function. So we follow this suggestion. We let u equal to what? U is what? U is this function. We let u equal to here ln x or dx. Of course, ln x. Yeah, the first choose means the ln. Yeah. So for the second here, for example, we have the x to the power 100 power times cosine x dx. Okay. So for example, find any derivative of x to the 100 power times cosine x. So for this, okay, for this one, we let u equal to x to the 100 power or x equal to cosine x. Why cosine x? So here, x to the 100 power is which function? Algebraic. Yeah? And cosine x is what? Is trigonometric. Yeah? So we let u equal to algebraic or trigonometric. So u is what? U actually is this part. Yeah? So we let u this part. So here means that we should be writing the x to 100 power and the d sin x. So this is u, this is v. Yeah?
No, she. Can you please give an example of an exponential function after?
So here, the exponential function actually means the a to the ex to the power x. Okay. Okay. So here, okay. I hope that everyone first can remember the formula. Okay. This is the first. The second, I hope that you can remember this suggestion. Okay. This suggestion, L-I-A-T-E. Okay. L-I-A-T-E. Logic-magic. So it was trigonometric and algebraic. And trigonometric and the exponential. Okay. So now I will give you some examples. So the first, we have 4, okay, we have 4 antiderivative. So the first is antiderivative of x times ex. The second is the antiderivative of ln x. The third is antiderivative of x squared times e minus x power, okay. So the fourth is the antiderivative of ex times cosine x. So for the first one here, okay, here means x ex dx. So now we need to choose u and v. So here for this function x, okay, x actually is an algebraic function, ex is exponential function, yeah. So we need to choose u equal to x or ex. X, yeah. So this is x. So this is u, yeah. So here means this part we can write it in the form dv, yeah. So dv, so here means that, here means dv, we need that equal to ex dx. So v actually is what? So here dv equal to ex dx. So here dv dx equal to ex. So here means what? Here means v actually equal to v plus 1. Okay, v plus 1 equal to ex. So v actually is what? So which function derivative equal to ex? So here v actually is the antiderivative of ex. Yeah. So antiderivative of ex is what? Is ex. Yeah. So ex. So here we can see. So here this is actually equal to, here is x and the dx. Yeah? Here is u, here is v. Yeah? Here is u, here is v. So here equal to, we use this formula, so equal to u times v minus v du. V is dx, du, u is x. So du is dx. So here, so now we can see if we have this choose a complicated antiderivative change to easy antiderivative, yeah? So antiderivative of ex is what? Is ex, yeah? So the result actually should be ex ex minus dx. Do not forget, okay? Do not forget a constant c, okay? So here, so it's easy, yeah? Easy? No. So you can see we have the formula and we have the suggestion. You just do it like follow this, okay? Is it easy? No. Now for the second, okay? For the second here. The antiderivative of ln x dx, okay? Ln x dx. So here actually we have a product of two functions, but here is just one function, okay? So ln x actually we can rewrite it in which form? Ln x actually we can see it is 1 times ln x, yeah? So here actually is 1 times ln x dx, yeah? So here we can see a function times another function. So here 1 actually is, we can see the x to the power 0, yeah. X to the power 0, so 1 actually is what function? Algebraic, yeah. Ln x is logic function, yeah. So we let u equal to what? U equal to ln x, yeah. So here we let u equal to ln x. And 1 times dx is equal to dv, yeah? So here, dv equal to what? Equal to 1 times dx. So here means what? Here means dv dx equal to 1. So v actually is what?
X.
So here actually v means equal to antiderivative of 1. So v actually is x, yeah? So here means that, so here equal to ln x dx. So we use antiderivative, we use the integration by parts. So this is u, here is u, here is v. Okay? So equal to u times v, so x times log x minus v du, yeah. So v is x, du is d log x, yeah. Can you understand here?
Yes.
So here, from here to here, can you understand? So from here to here, can you understand? Here is 1, yeah? The law is 1 dx. So 1 dx, we should do like 1 times dx equal to dv. So dv equal. So it means dv equal to 1 times dx. dv equal to 1 times dx. So here means we divided dx on both sides. So it means dv dx equal to 1. dv dx equal to 1 means what? It means v equal to any derivative of 1. So v actually is what? Any derivative of 1 is what?
X.
Is x. Yeah, so here means v is x. So here actually is so dv actually is dx. So here means u equal to log x, v equal to x. So we use this formula, okay? So equal to u times v, so x times log x. Minus v du, v is x, u is log x, so du actually is d log x. Yeah? So now let's see d log x. We have that. So here d log x, we have d log x dx equal to what? Log x derivative 1 by x, yeah?
Yes.
So 1 by x, so here means we times dx on both sides. So here means d log x equal to 1 by x dx, yeah?
Yes.
We times dx on both sides. We times x on both dx on both sides. So d log x equal to 1 by x dx. So here equal to what? So here equal to x log x minus x. D log x is 1 by x dx. So here x times 1 by x, 1, yeah? So here is 1. Here this part is 1. So this part is 1. So any derivative of 1? X. So the result actually is x log x minus x, yeah? So do not forget the constant c. Okay? So this is the result. So do you understand?
Yes.
Do you understand? So actually this is just remember the formula, okay? Remember the formula. Remember the formula and use the formula. So for this formula, okay, the key point is how to choose u. So how to choose u and v. So if you choose u, actually v is determinant, yeah?
So first we have to make it like u du, then we have to make it in log.
Why?
I'm saying the first everyone is x, ex, dx.
So here x is algebraic functioning, ex is the
Actually, I'm saying this function you made it like u dv and
yeah, so here is udv,
u dv. Then we have to make it uv minus du.
uv minus v du.
Yeah.
So from
then
here
we have to calculate.
So from here to here, so just find any derivative of ex. So the any derivative of ex is what? Is ex plus 3. Yeah? So this is the second, okay? Now for the third, okay? For the third, the antiderivative of x squared e minus x dx, okay? For this function. So x squared is Trigonometric function e minus x
E minus x.
is an exponential function, yeah?
Yes.
So we choose u is what?
X square.
X squared.
U is x squared, yeah?
Yes.
So here this part u is x squared, so this part e minus x dx, this part is dv, yeah?
Yes.
So here means what? Here means dv equal to e minus x dx, yeah? We need to find v, okay? Here, x squared is a trigonometric function. No, it's an algebraic function. And e minus x is an exponential function. So follow the suggestion. We should choose u what? X squared, yeah?
Yes.
X squared. So this part is u. So this part is what? This part is dv, yeah? This part is dv, so here means dv equal to e minus x dx. So we need to find v is what? So here means dv dx equal to e minus x, yeah? So dv dx equal to e minus x. So here means v equal to what? V equal to antiderivative of e minus x, yeah?
Yeah.
So antiderivative of e minus x is what? So here, for this one, antiderivative of e minus x, e minus x,
Minus E minus x.
actually this one should be minus e minus x. Okay, you can use u substitution, that u equal to minus x.
Yes.
So you will find that this part actually is minus e minus x. Okay. So here means b equal to this function. Okay. So here actually we can write it in the antiderivative of x squared d minus e minus x. Okay.
Okay.
So here this is u. This part is u, and this part is v. This part is v. So here equal to what? So here equal to u times v, so it's minus x squared e minus x. U times v minus v du. So v is minus e minus x. Yeah? And the v du, u is what? U is x squared. Yeah? So v du dx squared. So here we can see here minus minus, okay? Minus minus. So here this part is plus. Yeah? So here plus. So here dx squared, okay? So dx squared actually equal to what? 2x dx, yeah? Dx squared equal to 2x dx, yeah? Because here you can see dx squared dx derivative of x squared actually is 2x, yeah? And u times dx on both sides, so we have dx squared equal to 2x dx, yeah? So here we write this part as 2x dx. So here actually equal to minus x squared e minus x plus e minus x, and this part is 2x dx. So 2x dx. Okay? So here 2 is a constant. Here 2 is a constant, moves through the integral sign. So here. So here. Now we can see this is a function times another function. So here is a function times another function.
Again.
So we use the integration by parts again. So we choose u equal to what? U here is an algebraic function, here is an exponential function. So u is what? U is x. Yeah?
Yeah.
U is x. So this part times this part. Okay, this two parts actually related by So here I added here is x times e minus x dx. So this is u, and this part is dv. So dv equal to e minus x dx. So here means dv is what? So actually we just here is minus x squared e minus x. So plus 2, here is x. So e minus x dx equal to dv. So actually we just compute here. V actually is what? Minus e minus x. Yeah. So here is u, here is u, here is what? Here is v. Okay. So here is u, here is v. So we use the integration by parts again. So here you go to what? So here you go to minus x squared e minus x. So plus 2 u times v. U is x, v is minus e minus x. So and minus 2 v du. Yeah, v is e minus x du. U is what? U is x. Yeah. So we just need to compute this, okay? The antiderivative of e minus x. Now we can see here, okay? This is x squared times dx. We use integration by parts twice, okay? Twice. So here we just need to compute the antiderivative of e minus x. So e minus x. So antiderivative of e minus x is what? Minus e minus x. Yeah. So actually the result actually should be minus x squared e minus x minus 2x e minus x. Yeah. So here minus 2. This part is minus e minus x. So do not forget the constant c. Okay. So here minus minus. So here this part is plus. Okay, so the result here is should be plus 2e minus x. Okay, so this is the result. This is the result. Okay. So for this one, okay, for example 3, okay, for example 3, we use integration by parts twice. Okay. So you just need to know how to choose u, how to choose v, and remember the formula. Okay, remember the formula. So I have a break 10 minutes.